Hello and welcome to the video on adsorption isotherms. But before we start this interesting topic, let's first have a look at what adsorption is. It is basically a process whereby gas molecules adhere to stationary surfaces. In this case, it is activated charcoal. Adsorption can lead to multiple layer formations, single layer formations, as well as capillary condensation. So, what are adsorption isotherms? No, they're not slides. They're just graphs that show how different materials adsorb gases at a fixed temperature. There are 5 main types, but the scope of this video is to look at only the last 3. The graphs are plots of adsorption against pressure. Monolayer formations are modeled by the Langmuir equation and the multiple layer formations by the BET theorem. Now let's have a look at some examples from nature. The adsorption of carbon tetrachloride on macroporous surface like silica at 293 Kelvin produces an isotherm shaped like this. Whereas the adsorption of nitrogen gas on mesoporous surfaces such as porous glass at 73 Kelvin produces an isotherm that looks like this. And last but not least, the adsorption of water vapor on activated carbon at 1273 Kelvin produces an isotherm with such a shape. It can be seen that all the isotherms produced have the same shape as the primary isotherms type 3, 4 and 5. Let's now go into more detail. Type 3 isotherms are only produced on macroporous surfaces. There are no monolayer formations, only multilayers. Low adsorption at low gas pressure indicate low gas-solid affinity. As the pressure approaches the pre-saturation of the gas, the adsorption becomes infinite. Type 4 isotherms occur on mesoporous surfaces. They're similar to type 2 at low pressure. The monolayer formation is followed by capillary condensation. The surface saturates before pressure reaches saturated vapor pressure and it occurs due to capillary condensation. Type 5 isotherms also occur on mesoporous surfaces. They're similar to type 4, except that there's no monolayer formation. Low adsorption at low pressure indicates low gas-solid affinity. The surface saturates before pre-saturation and occurs due to capillary condensation. It can be seen that many isotherms behave similarly as type 3, 4 and 5. But why? The adsorption isotherm being produced depends on the gas being adsorbed and the surface of the adsorbent. As many surfaces are mesoporous and macroporous, they produce isotherms that are similar to the primary isotherm type 3, 4 and 5. And now, lastly, let's have a look at how adsorption isotherms are used in real life. They're used widely in the selection of material for catalysts in specific reactions. Adsorption isotherms are also very importantly used in determining surface area and surface properties of different materials. Thank you and have a nice day.